we've got a function f of x and we find f dash x, what that function does is it will give us the gradient of a tangent at any point on a curve. So if we find f dash 2, what that will do, that number there will be the gradient of the tangent at the curve. And once we find the gradient at a point, it's possible to find the equation of the tangent for any given point by using this particular formula here. And don't freak out, that's just m equals y2 take y1 over x2 take x1 transposed. So all we do is we write y2 take y1 equals m x2 take x1 in that transposed version, and that's what we've got there. To use this formula to write the equation of the tangent, all we need is a single point and the gradient, and we have it in y equals mx plus c form. So here's our graph, our parabola here, and what we've got is a tangent drawn to the graph at this point here, -2, -8. So there's our tangent there. Now remember the definition of tangent, what it does is that line runs along, nicks it momentarily at that exact point, and then continues along without touching that curve. So it intersects with the curve exactly once at a single point right there. All right, so first of all, what is the gradient of the tangent at x is equal to -2? So here's our original function. Remember, f of -2 gives us the y value at that point, which is -8. But if we want the gradient of the tangent, what we need is the gradient function. So let's get f dash x, the gradient function, and we've got 2x plus 2. So that's the derivative of the original. Right, and now what we'll get is the gradient of the tangent there. So f dash -2 equals 2 times -2, which is -4 plus 2 equals -2. So m, the gradient at this point, we're going to say is equal to -2. Now, what's the equation of the tangent at x is equal to -2? So I usually find it useful to write this in. Y take y1 equals mx take x1. And I have the gradient there, and I also like to write the coordinate point. I know it's already written there, but I'll rewrite it there with x and y. All right, so this is y take y1, so we'll call this y1. Y plus 8 equals m, which is -2, x take x1, x plus 4. Generally, we would put this into the correct form, like a y equals form. So what we'll do is we'll expand this, which is -2x take 8, and then we're going to subtract another 8. Therefore, our equation of the tangent is y equals -2x plus, no, not 16. Why is it 16? There's my mistake there. Let's rub that out. That should be plus 2. That should be -4. So take 8. That should be 12. Right, we can see that our equation there runs through what looks to be -12 down there. And that's why I knew that it couldn't have been 16, because I had a quick look at the graph, knew that -16 was down here. That's just way too low for that tangent. So it had to be something different. So you can pick up your mistakes quite well if you can check them off against the graph. All right. Find the equation of the tangent to the curve y equals that at the point x is equal to 1. All right, so usually I like to work in function notation. So we'll say let y equal f of x. Okay, so we're going to change the definition of that to be f of x. And what we'll do is we'll find the gradient of the tangent at x is equal to 1. So let's get our gradient function. That's 3x squared plus 2 times a half is 1. Raise that power, or drop that power down by 1 is x. Right, at x is equal to 1. So we'll do f dash 1 equals 3 plus 1 equals 4. Therefore, m equals 4 at the point. All right, now speaking of the point, in the first example we had, or we're given a point -2, 8. This time we're given the x value of the point. We need to find the y value of the point. They haven't given it to us. But it's fairly easy to get. All we'll do is we'll do f of 1. All right, so let's bang 1 into the function. We've got 1 plus 1 times a half is a half, which is 3 on 2. Right, so our point is 1 comma 3 on 2. And now we can pop all of this into y take y1 equals m x take x1. Right, so let's pop those values in. So we've got y take 3 on 2 equals m, which is 4, x take 1. Y equals 4x take 4 plus 3 on 2. Now that one there will be negative 8 on 2. So y equals 4x. So negative 8 on 2 plus is negative 5 on 2. Right, so we can quite easily check this using some sort of graphing program like GeoGebra. So let's graph our original function, which was y equals x cubed plus half times x squared. And what we'll do is we'll graph our tangent as well, which is y equals 4x take, what was it, 5 on 2. And what we can see quite quickly is that we've got this tangent drawn here at this point, and the point was when x is equal to 1. So when x is equal to 1, that's when we get the tangent, and I think the y value is 3 on 2 there, so it definitely looks to be correct. We can zoom in here, and we can see even better that it just nicks it at that point. I know it looks like it rubs along the line a long way, but if I zoom in far enough, we'll see that it just intersects momentarily at one particular point, at x equals 1, right there. Okay, you'll often be asked for the equation of the normal to a point as well. So what the normal is a line that runs perpendicular to the tangent at the point. Okay, I don't know whether VCAR, apparently they've changed the wording of that to be perpendicular to the point, and they don't use the word normal anymore. But the function on our calculator is called normal, so I'll continue to refer to it as normal, but you just got to know that the definition of normal is perpendicular to the point. You'll recall that if a line has a gradient m, then the normal will have an equation negative 1 on m, the negative reciprocal. So I don't know whether you remember that from linear. So if we've got a line here, y equals negative x, our gradient of this line, well, not negative x, that's positive x. Our gradient there is 1. If I find the negative reciprocal for that, m2, it's negative 1. That will give us a line running at 90 degrees or perpendicular to this line here. So we do exactly the same thing as we've been doing with one minor change. So find the equation of the normal to the curve with this equation at 1 comma negative 1. So I think the first thing we'll do is let y equal f of x, so we can use some function notation. We'll find the derivative function, which is 3x squared take 4x. All right, now f dash 1 is going to be 3 take 4, which is negative 1. So m at the point is negative 1. And I'm going to call this m1. Okay, the gradient m1 at the point is negative 1. So the normal is going to have a gradient that's the negative reciprocal of this line. So m2, the normal, is going to be negative 1 over 1 negated, which is going to be 1. Right, and we've been given the point here, so we're going to go y take y1 equals m x take x1. All right, now what we will do is sub in that point, so there's our x and there's our y. So we're going to go y plus 1 equals 1x take 1. X take 1, y equals x take 2. Right, and if we graph this, what will essentially happen at the point 1, 1 is if the tangent would go that way, the normal will be that way at 90 degrees to the normal, at 90 degrees to the tangent. Okay, we can use a calculator to do this quite efficiently. Right, so what we'll do is we'll calculate the equation of the tangent and equation of the normal for this particular function here when x is equal to 1. find the best way to do this is to define the function. So what we'll do is we'll go to keyboard, hit the define function. So define f of x equals 3 take 2x squared. All right, and then it's a simple case of going to interactive, calculation, and line. And there's two options that we're really interested in here. It's tan line or normal. Let's go tan line to get the tangent line. So we're going to do that for our function, which we've called f of x. At the point described here, which is 1. And what that will do is return the tangent to this at x is equal to 1. And normal works exactly the same way. So line, normal, for f of x at the point x is equal to 1. And there's our normal. And you can see here, like what we've got is a gradient of -4 there, and the normal has a gradient of the negative reciprocal of that, so 1/4. Okay, a couple more questions. Find the equation of the tangent and the normal to the curve where the curve cuts the y-axis. So where does it cut the y-axis? It's when x is equal to 0. So it looks to be -2 in the picture, and it certainly is -2 according to the function. So our point is going to be when x is 0, y is -2. All right, so now all we need is the gradient of the tangent at that point, at this exact point here. All right, so we'll go let y equal f of x, get our derivative, 3x squared take 5, and find out what its gradient is at x is equal to 0, which is -5. Seems to be appropriate. All right, so now we've got our equation, y take y1 equals mx take x1. Right, but what we could hopefully see fairly quickly is that our y-intercept is going to be -2. We already know that, and our gradient is -5. So I know that the answer will be y equals -5x take 2. Let's just find out. So what I'll do is sub in these points. So y plus 2 equals 5, -5 rather, x take 0, which is just x. Y equals -5x take 2, which I knew would be the case. So out it pops using the formula, but visually you can see that that tangent is going to go through -2. All right, now the normal is, so this is the tangent at x equal 0. We can get the normal by finding the negative reciprocal of that, and the normal will be the line that runs 90 degrees or perpendicular to the tangent at that point. So that's going to be same y-intercept, different gradient. Y equals, so I'm going to get the negative reciprocal of that, which is 1/5x take 2, or x on 5 take 2. So that's the normal at x is equal to 0. Okay, last problem. Find the equation of the tangents to the curve, and notice that they say tangents here. Y equals at the point where they are parallel to the line, y equals 2x plus 3. Right, so going to be a bit of work involved in this one. So firstly, what I'm going to do is find out for what values of x, because there's going to be two tangents, where they're parallel to the line y equals 2x plus 3. Let's just quickly sketch that as well. So we've got 3, right, and a gradient of 2, x equal to 1, I'll go that by 2. So this is our line here. And what we want to know is when, or the equations of the tangents that run parallel to this line. So I can sort of see that there's going to be one around here and one here. So I'm presuming that the x values are going to be like -3 and maybe 1 or something like that. All right, so what I'm going to do is get my derivative function. So let y equal f of x, get f dash x, which is x squared plus 2x take 1. And this time, because I'm trying to find out the x values for which this occurs, I'm going to say, when does this, the gradient function, equal 2? That is, when do you have a gradient of 2? So I'm going to let f dash x be equal to 2. We might recall with quadratic functions, we need to let them equal 0, or let one of the sides equal 0 to apply the null factor law. So it's that one. X is equal to 1, and x is equal to -3, as we thought in the picture. That's pretty lucky. All right, so once we know that, okay, we know that these are the points where this occurs. We know the gradient at that point, so the point is going to have a gradient of 2. What we just need is a y value for these points. So we'll do f of 1 and f of -3 to get the y value. So f of 1 is going to be 1/3 plus 1 take 1 plus 4, which is equal to 4 1/3, which is equal to 13 on 3. So there's our y value there. So our coordinates are going to be 1, 13 on 3 for that particular point. Okay, so 1, 13 on 3, that's that point. And the other one, we're going to put in -3. So -3 cubed is -27. And 1/3 of -27 is -9, plus 9, plus 3, plus 4. These cancel out, and we've got 7. So our other point is -3, 7, which certainly looks appropriate. So -3, 7. Right, so now what we'll do is we'll use our formula y take y1 equals m x take x1. Let's do it for this one first. So y take 13 on 3 equals 2 x take 1. Y equals 2x take 2 plus 13 on 3. Y equals, so that will be -6 on 3. -6 from 13 is 2x plus 7 on 3. So there is the equation of this tangent. All right, onto this one. We've got y take y1, which is y take 7 equals 2x plus 3. Y equals 2x plus 6 plus 7. Y equals 2x plus 13, which does look reasonably appropriate. So there's our second equation there. All right, so your job now is to just jump over those questions there and hit 18A doing those problems.